concept of equivalence. Right, concept of equivalence. Now, what do we mean by the concept of equivalence? That is important to understand. Now, just see. So, you have to understand that what is an equivalent mass? What is an equivalent mass, right? Now, you got to understand a very, very important concept. Now, what did it say? It says that let's suppose we have aluminium, right? So, for that, we know that 1 mole of aluminium weighs 27 grams. Yes or no? 1 mole of aluminium weighs 27 grams. Am I right?
Yes.
Yes or no? So when
Yes.
1 mole of aluminium weighs 27 grams, what does that mean? Tell me. When 1 mole of aluminium weighs 27 grams, so it is very simple that we know that aluminium releases 3 electrons, because if it ionizes, its atomic number is 13 and its configuration is 283. So what will aluminium do? Aluminium will form Al plus 3 and will lose 3 electrons. Am I right?
Yes.
Now when aluminium loses 3 electrons, so how should I say this equation? I would be saying that 1 mole aluminium releases 3 moles of electrons, which could be another way of saying that, that 3 moles of electrons are released by 1 mole aluminium. And 1 mole aluminium is given by, so I would say 3 moles of electrons are given by 27 grams of aluminium. As to why am I saying this? Because you understand that 27 grams of aluminium is nothing. 27 grams of aluminium is nothing, but just what? It is just 1 mole of aluminium itself. But it's just that how you write it down. Am I right?
Yes.
Yes or no? So now, what do we understand from this part? So you have to calculate that 1 mole of aluminium, 1 mole of electrons are released by, so if 3 moles of aluminium, if 3 moles of electrons are
So
given by
1 by 3
27
moles of
moles of
aluminium.
right? So 1 mole of electrons would be given by, how do I make 3 as 1 here? I divide by 3. So I divide by 3 on the left, so I have to divide by 3 on the right also. So if I have to divide by 3 on the left, I will have to divide by 3 on the right. Am I right? So dividing 3 here and dividing 3 here. And hence, what do we get? We get 27 by 3, that is 9 grams. Yes or no? So we have 9 grams of aluminium being able to give off 3 moles of electrons. To be able to give off 1 mole of electron. So I would say that 9 grams is the equivalent mass of aluminium. So basically you have to understand that what is the equivalent mass. Equivalent mass is basically the mass which can give off 1 mole of electrons. Do you understand?
Yes.
Which can give off 1 mole of electrons or which can gain in 1 mole of electrons. Now let us suppose I'm talking about let's say nitrogen atom. So I would say what? That nitrogen's atomic number is 7.
So it'll be the same. It will be 14 by 3.
Exactly. So what would you say? That its valency is 3. That means nitrogen has the tendency to gain 3 electrons to form N-3. So according to this equation, I would say 1 mole nitrogen would gain 3 moles of electrons. And 1 mole nitrogen is basically 14 grams. So I would say that 3 moles of electrons are gained by 14 grams nitrogen. So 1 mole of electrons are gained by 14 by 3 grams of nitrogen. So hence 1 mole of electrons are gained by 14 by 3 grams of nitrogen, and hence I will call this as the equivalent mass of nitrogen. So basically 14 by 3 is nothing but E. 14 by 3 is nothing but E of nitrogen, and similarly E of aluminium was nothing but 9 grams.
Yes.
Is this concept clear? Yes or no? Right. Now you have to understand in this concept. Now let's suppose I give you one example. Let's suppose I give you, I have to make Mg and O2, right? So this is going to be the law of chemical equivalence. Now how does this law works? It is a law of chemical equivalence. Now what does this law basically tells you? Just see. So law of chemical equivalence tells you that Mg plus O2 shall give you what? MgO, right? Mg plus O2 shall give you MgO. Now, in this example, what exactly do you think is going to happen? Just see. When we are talking about the law of chemical equivalence, so Mg is 24 grams molar mass. And O2 is a molecule. Now, understand very important part. Let's suppose I have one packet of magnesium. And in that I have, you understand from here, that magnesium wants to gain 2 electrons. Sorry, magnesium wants to lose 2 electrons. To lose 2 electrons.
So it's
In
equal
order
mass.
to complete circle. So 2 at 2. And hence it becomes Mg plus 2. Am I right?
Yes.
So I would say that 24 grams of magnesium, basically 2 moles of electrons are lost by 24 grams of magnesium. So 1 mole of electrons are lost by 12 grams of magnesium, because 24 by 2. So I'm going to get 24 grams of magnesium. So if I say equivalent, now understand. If I say 1 gram equivalent, so 1 gram equivalent is a packet. Gram equivalent is a packet. Did you understand my point? So when
Yes.
we talk about the gram equivalent, what exactly does that mean? That it is that one packet of an element which can release of 1 mole electron. So I would say in this 1 gram equivalent packet of magnesium, I am going to fill in 12 grams of magnesium. Why? Because I know that 12 grams of magnesium is going to release 2 moles of electrons. Did you understand my point? It is going to release 1 mole of electron.
Yes.
Any doubts on this? Right? So when we have this concept, very, very well-defined concept, now you talk about oxygen. Now, when we talk about oxygen, what would I say? I would say that 1 gram equivalent of oxygen, 1 gram equivalent of oxygen is going to be what? So I'm going to say that O. Now, in the reaction, first of all, you understand that it is the atom which participates, right? And not the molecule. So even if you're writing down O2, O2 is definitely going to break down, come back into O and O, and hence
It
the
will become.
reacting entity would be oxygen atom, right?
Yes.
So atomic number of oxygen is 8. So the configuration is 2, 6. So we know that it is going to gain 2 electrons, and hence it is going to form O minus 2.
Yes.
Yes or no?
Yes.
And when it is going to form O minus 2, you got to understand that I would say that 8 grams of oxygen requires. So 2 moles of electrons are gained by 8 grams of oxygen. Sorry, by 16 grams of oxygen. What is the molar mass of oxygen? I'm so sorry, that's 16 grams, right? So I would say 1 mole of electrons are gained by 16 by 2. That is 8 grams of oxygen.
Yes.
So I would make one packet. That one packet, I will name it as 1 gram equivalent. So equivalent is a packet. So 1 gram equivalent of oxygen will contain how much mass? 8 grams. Why? Because that 1 gram equivalent means that it is that amount of oxygen. It is that packet containing oxygen which would gain 1 mole of electrons. Do you understand my point?
Yes.
which would gain 1 mole of electrons. Any doubts in this? Just tell me. Yes or no? Right. So when we are talking about this particular part, you have to understand that 1 gram equivalent of oxygen is going to be this. Now I have 2 gram equivalents. 1 gram equivalent of magnesium and 1 gram equivalent of oxygen. So now you understand. So let's suppose if I say I have 1 dozen apple. If I have 1 dozen apple,
Yes.
and if I say if I have 1 dozen watermelon, you tell me one very important part. 1 dozen watermelon and 1 dozen apple. What does that mean? The number wise, it is 12 apple.
Yeah, they're the same.
Number wise, it is 12 watermelon. Right? So number wise, it is 12. But do you understand that mass wise, 1 dozen apple might be 1.5 kgs, whereas 1 dozen watermelon might be 30 kgs. Mass wise, they would be different because obviously the watermelons are heavier and apples are smaller and lighter. Yes or no? So you have to understand that number wise they are same, but mass wise they are not same. Yes or no? So mass wise they are not same, but number wise definitely they are same.
The same.
You understand? So similarly, if I say I have 1 gram equivalent of magnesium and I have 1 gram equivalent of oxygen. So I would say, okay, I have 1 packet containing magnesium and I have 1 gram equivalent of magnesium and I have 1 gram equivalent of oxygen. Are you understanding?
Yeah.
Do you understand my point?
Yes.
And that contains 12 grams magnesium and that contains 8 grams oxygen. Because I know for the fact that 12 grams of magnesium can donate 1 mole electron. But the same number of electrons, 1 mole electrons, will be gained by 8 grams of oxygen. Are you understanding?
Yes.
So you understand one very important thing. Now let's suppose in a reaction, I have 2 packets of magnesium. So 2 packets of magnesium means 2 gram equivalents of magnesium. Gram equivalents. So that means 1 gram equivalent will contain its equivalent mass. That is 12 grams and another 12 grams. And let's suppose I have only 3 packets of oxygen. 1 gram equivalent, 1 gram equivalent of oxygen, another 1 gram equivalent of oxygen, another 1 gram equivalent of oxygen. Now, you tell me a very important point here. Tell me that let's suppose we have 8 grams of oxygen here, 8 grams of oxygen here, and 8 grams of oxygen. So you have to understand that one very important key point, that 1 gram equivalent contains equivalent mass. 1 gram equivalent contains equivalent mass of the respective element. So you can have any element and you can calculate its equivalent mass accordingly. You understand my point?
So 1
Now,
gram equivalent for aluminum is 9 grams.
9 grams, yes. So if you make 1 gram equivalent packet of aluminium, it would have 9 grams of aluminium present in it, right?
Yes.
And 1 gram equivalent packet or whatever mass of that element is being filled in there, it would lose or gain 1 mole of electron. You understand? Just give me a second. Right. So 1 gram equivalent shall contain E equivalent mass. So now you tell me very simple rule, that will this 12 grams give off 1 mole electrons? Will this first packet give me 1 mole electrons out? The second packet shall also give me 1 mole of electrons. Because 12 grams of magnesium would just be half a mole of magnesium. And every mole would give you 2 moles of electrons. And now you have to understand that these 8 grams of oxygen is capable of gaining 1 mole of electrons. Another 1 mole of electrons shall be gained by, but what will this third gram equivalent, this third packet of oxygen gain? Nothing. Because here, what exactly do we have? What do we have in here? Here, what do we have? Tell me. Tell me, here what do we have? We have two packets. So one packet reacts with the first packet, second packet reacts with this packet. You
Yes.
understand?
Yeah.
But for the third packet, there is no third gram equivalent here.
Yes.
That means what? That I should say that first of all, we know that a metal reacts with a non-metal. So the number of electrons lost by one packet, the number of electrons lost by one first packet has to be gained by the other packet. So no matter what the mass is in that packet, no matter what the equivalent mass is in that packet, should I say the number of packets on the left hand side must be equal to the number of packets on the right hand side? That means 3 packets of magnesium should have been there.
Yes.
Yes or no? Should
Yes.
have been there. And here, 3 packets of oxygen must have been there.
Yes.
Yes or no? 3 packets of oxygen must have been there. So that exactly means what? That exactly means what? That ma'am, if we have 3 packets of magnesium, there must be 3 packets. That packets means gram equivalence of oxygen must be there. Are you understanding my point?
Yes.
Very, very simple important. Okay?
Yes.
Got the point? So
Yes.
this is the law of chemical equivalence. It says if we do not know the balanced equation, one thing for sure, one thing is definitely sure that if I have an equation A plus B gives me C plus D, then definitely the number of packets, that is the gram equivalence
They
of
must be
A,
same on both sides.
they must be equal to the gram equivalence of B, and hence they would produce a gram equivalent of C, and that would also be equal to the gram equivalence of B. Do you understand my point?
Yes.
So what is the definition of a gram equivalent? What is the definition of a gram equivalent? So 1 gram equivalent in general, because I am going to tell you this equation, which is going to be applicable everywhere. So 1 gram equivalent in general would mean the mass of an element generally in the atomic form, the mass of the element in the atomic form, or the compound which can lose or gain or transfer, lose or gain or transfer 1 mole of electrons. That is that packet, and that mass, the mass filled in that gram equivalent is called as the equivalent mass, is called as the equivalent mass. Did you understand my point?
Yes.
Right? And I would say that the number of gram equivalents, this is the law of chemical equivalence. Law of chemical equivalence. That means the gram equivalence of the reactants must be equal to the gram equivalence of the products. Is this point clear?
Yes.
Okay. Now, basically, these kind of questions generally come up. Okay. Any doubts in this? Just tell me.
No.
All right. Now,
Yes.
let's just see. So basically, we have this particular part, right? Now, see. So let's suppose I have. So for metals, so do you realize that every element has some element might gain n electrons to form E minus M. So what would I say? And M is the molar mass of the element E. So what should be my statement? That n moles electrons are gained by m grams of metal,
Yes.
of element,
Yes.
and hence 1 mole of electrons shall be gained by m by n grams of the element. And hence m by n would be the equivalent mass. Yes or no? The first relation that we get is that molar mass. What is m? M is the molar mass.
Yes.
So molar mass upon n would be equals to the equivalent mass. Do you understand my point?
Yes.
So first relation between the molar mass and what is n here? Generally that n is called as the n factor. But for the elements, it is the valency. It is their valency. It could be a metal or it could be a non-metal. Doesn't matter. It doesn't matter. So basically, how do we move ahead in this? The n factor equals to n. N here means the valency of that particular element. For the elements, it is the valency of that particular element. Do you understand my point?
Yes.
Right. Second point is, how do we calculate the n factor for acids and bases? How do we calculate the n factor? Because the basic part remains the same. Now, you understand a very simple question, right? Now, before doing acids and bases, I'll discuss a very important rule here. What does it say? Just see. What does it say? Just see. It says that let's suppose we have a compound called Al2O3. We have a compound now. And I want you to calculate the equivalent mass of Al2O3. I want you to calculate the equivalent mass of Al2O3. So how exactly do you think we got to calculate the equivalent mass of Al2O3? Just see. So when we are calculating the equivalent mass of Al2O3, we have to understand a very basic part of it, which says that, we have 2 aluminium plus and we have 3 oxygen minus 2. Am I right?
Yes.
That means there would be 2 aluminium atoms and there would be 3 oxygen atoms. Now, oxygen has atomic number 8, which is configuration 2, 6, and it requires 3 electrons. So for every oxygen, I'm going to draw 6 electrons with the condition that obviously it is needing to gain 2 electrons. So for here, another oxygen, I would draw another 6 electrons. And for another oxygen, I would draw another 6 electrons. Yes or no?
Yes.
For aluminium, I would be having 3 electrons. For aluminium, I would be having 3 electrons because aluminium's atomic number is 13. Configuration is 283. Am I right?
Yes.
So that aluminium is definitely going to lose 3 electrons, right? Now, what is going to happen? Just see. Now, aluminium donates its 3 electrons, 2 to this oxygen, 2 to another oxygen like this, and 2 to the third oxygen. Are you understanding?
Yeah.
And when this happens, you understand when this is happening, this part, the third oxygen is getting electrons like this. So 2 are getting here, another 2 are getting here, another 2 are getting here. What do you understand from this? That how many electrons are being transferred in totality? Because when this entire thing happens, then only Al2O3 is formed. So what would I say? I would say that during the formation of 1 mole of compound Al2O3, during the formation of 1 mole of compound Al2O3, 6 moles of electrons are getting transferred. Do you understand? During the formation of 1 mole of compound Al2O3, 6 moles of electrons are getting transferred. And
Yes.
what is the molar mass of Al2O3? Let's calculate. It is 27 times 2 plus 16 times 3. That's the molar mass of Al2O3. What is that? That is 54 plus 48. And that is 12. And that is 102 grams. You understand? So I would say that 6 moles.
102 by 6.
How much is that? 102 grams, right? So 6 moles of electrons are being transferred to
18.
make 102 grams of Al2O3. So if only 1 mole of electron transfer would have taken place. So for 1 mole of electron transfer, we would have got 102 by 6 grams of aluminum Al2O3. And that mass is 102 by 6 grams of Al2O3. That would mean 2 times 3 and 2 times 51. You understand? And that's 17 grams. So basically 17 grams of Al2O3 is the mass formed when 1 mole of electron transfer is taking place from aluminum to oxygen. So I would say that 1 gram equivalent of Al2O3 is containing 17 grams of Al2O3.
7.
Are you understanding my point? Any doubts on this?
Yes.
Do you understand?
Mm. Yeah.
Any doubts on this? Just tell me.
No, I don't know.
Any doubts on this, right? So when I basically talk of 17 grams of Al2O3, you have to understand that for a compound made up of 2 or more elements, how do you calculate the equivalent mass? Now, just have a look here. The number, the n factor with which I divided, it was 6. Just have a look here. Al2O3, if you remember, that Al2O3 is actually formed by the crisscross of the 2 species. So one species Al plus 3 and another species O minus 2, if I'm not wrong. Right? And how many Al plus 3 I would be needing? 2. And how many O minus 2 I would be needing? 3. So if I break it, half part of it is positive, half part of it is negative. Do you understand? Half part of it is positive and half part of it is negative. So I would see that, if one aluminium acquires a plus 3 charge, so 2 aluminium would acquire. So basically we have 2 Al plus 3 in Al2O3. And we have 3 O minus 2 in this compound. So we would have a total charge of minus 6 here. And we would have a total charge of plus 6 here. So if I just take the magnitude of the total positive or total negative charge, do you realize that that is what I divided 102 by 6? So basically
Yes.
m by n factor is my equivalent mass. So from here I can see that the equivalent mass here is 6. Are you understanding? What are we going to do? So we wrote that, m by 6. What do? We did 102 by 6. And we got 17. That is the equivalent mass of Al2O3. So what did I just explain to you? That Al2O3 consists of Al plus 3 2 times and oxygen O minus 2 3. So what is the total positive charge here? So what is the total positive charge here? That is plus 3 and plus 3 plus 6. And what is the total negative charge here? That is going to be minus 2, minus 2, minus 2. That is going to be minus 6.
Yes.
So if I just take the mod of it, do I get 6? And
Yes.
that is what I am dividing it here.
So the equivalent mass of Al2O3 is 17.
Right. But how did we get to 17? We found the n factor. And what is n factor? The n factor here would be the total positive charge or the total negative charge. You understand?
Yes.
The n factor here would be the total positive charge. Because see, when you say 6, that means total 6 electrons are being transferred to oxygen. All the 3 oxygens in totality would be gaining. Okay, in totality, they would be gaining how many electrons? They would be gaining 6 electrons, and total aluminium would be losing 6 moles of electrons. Did you understand my point?
Yes.
So, for example, if I have a compound called ALN, that is aluminium nitride. And it is true for all the compounds, right? All the ionic compounds. So if I say aluminium nitride, So what does aluminum nitride means? What does aluminum nitride means?
Isn't it
Aluminum nitride is
Al?
basically 1 Al plus 3 and N minus 3 because aluminium's atomic number is 13 and nitrogen's atomic number is 7. So aluminium is 283 and nitrogen is 25. So nitrogen would be gaining 3 electrons and aluminium would be losing 3 electrons. Did you understand my point?
Yes.
So aluminium shall form Al plus 3 and nitrogen shall form N minus 3. Do you understand? And hence what is going to
Yes.
happen? We are going to have Al plus 3 and we are going to have N minus 3. So what is the total positive charge? That means aluminium has 3 valence electrons. Nitrogen has 5 valence electrons. And there's a transfer of 3 electrons. So I would say to form, what is aluminium's molar mass? Aluminium's molar mass is 27 and nitrogen's molar mass is 14. So that is 11 and that is 41 grams. So that is the molar mass. So I would say 3 moles of electrons are transferred from aluminium to nitrogen to form 1 mole aluminium nitride. So 1 mole electron transfer and 1 mole aluminium nitride is basically 41 grams of aluminium nitride. That's the molar mass. So 1 mole electron transfer would take place 41 grams of aluminium nitride by 3. So I would say the equivalent mass would be 41 by 3 grams of aluminium nitride. Did you understand?
Yes.
So for a compound, how should I define? For a compound, for an element, I defined that it was molar mass by valency. For a compound, it would be equivalent mass would be molar mass. Ideally, I should write down total electrons transferred from metal to non-metal. But that would also be basically written down in books. How it is written down? Molar mass upon total positive charge or total negative charge. One of those things. Either total positive charge or total negative charge, they are mod. Right? Because when you have a neutral compound being formed, for that neutral compound, total positive charge come on. Did you understand my point?
Yes.
That is the equivalent mass. And that equivalent mass is filled in one packet. And that one packet is called as 1 gram equal. Did you understand my point?
Yes.
That 1 gram equal. Understood or not?
Yes. Yes.
Right. Next, what do we have in here? Next, we have for an acid and a base. Equivalent mass, equivalent mass for an acid or a base. What would that be? Equivalent mass for an acid or a base. What would that be? Now let's calculate. Now let's suppose we are talking about an acid HCl. So I know that that one acid is going to give me H plus and Cl negative. Right? That's how HCl breaks down. HBr will be breaking down in the form of H plus and Br negative.
Wait, so it's equivalent mass is just 18 for NCL.
Yes, that will be molar because now you treat every acid like a compound. So you can apply the same formula, that molar mass over N factor. The
Yes.
same formula you can apply, this formula. Did you understand?
Yes.
Right?
Yes.
So you have to understand that you can apply the same formula here. But if I have to actually talk in terms of the equivalent mass, how does it basically work? So you understand this acid HCl is giving me 1 mole of electron, 1 mole of H plus. And 1 mole of H plus can accept 1 mole of electrons. Are you understanding?
Yes.
So in totality, if I say that, HCl overall can accept how much electron? So you say you give 1 mole of electrons to HCl, and that is going to gain H plus. That is going to gain H plus. Did you understand?
Yes.
Right. Similarly, when we are talking about HBr, what exactly does that mean? That you gave it 1 mole of electrons to H plus, and that 1 mole of electrons shall be gained by, that 1 mole of H plus shall be gained. 1 mole of electrons shall be gained by H plus. Did you understand?
Yes.
So ideally, how do we say? Or in, let's suppose I'm talking about a base, I'll say that CaOH whole twice shall break down to give me Ca plus 2 and 2 OH negative. Am I right? So
Yes.
when it is going to give me 2 OH negative, what exactly does that mean? That 1 OH negative, in order to become neutral, shall lose 1 mole of electron. Did you understand?
Yes.
So 1 OH negative, in order to lose that, it is going to lose 1 mole of electron. Did you understand, Babu?
Yes.
So similarly, 2 OH negative, in order to become neutral, shall become what? Shall lose 2 moles of electrons.
Yes.
So I would say that in totality, this 1 mole of calcium hydroxide, whose mass would be what? 40 plus 16 times 2 plus 1 times 2. So that's going to be 40 plus 32 plus 2. So that's going to be 40 plus 34. That is 74 grams of calcium hydroxide shall give off 2 moles of electrons. Yes or no? So 1 mole of electrons shall be given by 74 by 2. That's going to be 37 grams of calcium hydroxide.
Understood.
So I would say 37 grams would be the equivalent mass. So how do the books state it? They would say that the equivalent mass of an acid is equals to the molar mass of the acid
Divided by
upon
acidity.
the number of H plus ions released.
So by acidity. Yeah.
The number of H plus ions released, which you also called as a basicity of an acid.
Then acidity of a base.
Yeah, acidity of an acid. And similarly, if you talk about the equivalent mass of a base, that would be the molar mass of the base.
Yes.
That would be the molar mass of the base divided by the number of OH negative ions released by the base,
Yes.
which would be the equivalent mass of the base would be the molar mass of the base upon, which is also you call as a acidity of the base. Acidity of a base by itself means acidity of the base by itself means what? That it is going to do what? Acidity of the base basically means what? It is going to
The n factor of the base.
the number of, yes. So for n factor, this would be the value.
Yes.
You understand my point?
Yes.
Got my point? Concept clear?
Yes.
So E acid, E base is this value. E compound would be the total positive charge or the total negative charge. Now you understand. Now let's suppose if I talk about chlorine. Now let's suppose you got this molecule, right? Now how do we calculate the equivalent mass of a molecule? Now I'm going to give you this rule that equivalent mass of a molecule is nothing but equivalent mass of the atom. Now both the atoms of chlorine are exactly of the same type. So equivalent mass of the molecule is definitely going to be the equivalent mass of the atom. Yes or no?
Yes.
So for Cl2, if we talk about, what exactly do you think is going to happen? You'll say 72 grams molecule. This is chlorine molecule. Now, when we talk about the chlorine molecule, it is 1 mole chlorine molecule. So 1 mole chlorine molecule means that would be 2 times 35.5 grams of chlorine molecule. Yes or no?
Yes.
So that is 71 grams of chlorine molecule, right? So in totality, if we talk about one chlorine atom, I would say the molar mass is 17. So atomic number is 17. So the configuration is going to be 287. Yes or no?
Yes.
The configuration would be 287. So you have to understand that it would be what? It would be 35.5 times 2 grams of chlorine molecule would gain how much? Because if I have to say that chlorine molecule Cl2 will break down into 2 chlorine atoms and every atom will have a configuration of 287. So shouldn't it gain 2 electrons to make 2 Cl negative? Because every chlorine somewhere down the line has to gain 1 electron from where? You understand?
Yes.
So what exactly do you understand from this part? Tell me. What exactly do you understand from this part? So this is going to be what? It is going to gain 2 moles of electrons. So I would say 35.5 times 2, that is 71 grams of chlorine shall gain 2 moles of electrons in order to complete its octet. So I would say that in order to gain its octet, so 2 moles of electrons gains 71 grams of chlorine are gained by 71 grams of chlorine. So 1 mole electrons shall be gained by 1 mole electron shall be gained by 71 by 2 moles. So shouldn't it come out to be 35.5 grams?
Yes.
That is the equivalent mass.
Mhm.
And here you understand, if I would have been calculating it only for the atomic chlorine, what would I do? 1 chlorine atom, 1 mole chlorine atom will gain 1 electron to form Cl negative. So I would say the 1 mole atom's mass is 35.5 grams only. So 35.5 grams
If you
gain.
want to say by 1 is just 35.5. There's no difference between that of molecule and an atom.
Yeah, so the answer comes out to be the same. So there is no difference in the equivalent mass. So I would say the equivalent mass of P4 is same as equivalent mass of P. Equivalent mass of O2 is same as equivalent mass of O.
Yes.
But the statement wise, when you calculate it, when you write down the statements, it becomes a little bit different value. So here it would be 31 by 3 grams. You understand?
Yes.
So this is the basic concept of equivalent mass. Now next is the equivalent mass of the gases. Equivalent mass of the gases. In the equivalent mass of the gases, how do you do? Let's suppose you have CO2 and I want you to calculate the equivalent mass of CO2. What you do is you dissolve that CO2 in water. Dissolve and react it. So it is going to form H2CO3, which is going to be my carbonic acid. Which is going to be my carbonic acid. And hence, if I have H2CO3, that is my carbonic acid, what do you understand from this point? That H2O plus CO2 shall give you H2CO3? Yes or no? H2O plus CO2 shall give you what? Carbonic acid?
Yes.
And for carbonic acid, I can see it is going to give me 2H plus. So the N factor for acid would be 2 here. And whatever is the N factor of the acid is the N factor of the gas. So the basic rule here is N factor of the gas is equals to N factor of the acid. Do you understand my point? N factor of the gas is equals to the N factor of the acid.
Yes.
Right?
Yes.
That is the concept.
Some
Similarly,
the questions.
sorry?
Some questions.
Yeah, we'll be doing questions, but let me complete the concept of the equivalent mass. I didn't get your query. So next is, what do we have? Let's suppose I have SO2 and I dissolve that in water. What acid will I get? Simply added up H2, SO3. That is my sulfurous acid. And this sulfurous acid shall give me 2H plus. NSO3 minus 2. So N factor here for this acid would be 2. And hence I would say N factor for SO2 is also 2. Did you understand my point?
Yes.
Right or not? Any doubts on this?
No.
So we have this particular concept of equivalent mass, right? Did you understand?
Yes.
So just understand a very, very basic difference here. So how do you actually calculate the number of gram equivalents? How do you calculate the number of gram equivalents? Now let's suppose I say, how do you calculate the number of gram equivalents? Now let's suppose I say, what? I'll say that I have, let's say, number of gram equivalents. Let's suppose I have 54 grams of aluminium. And that is my given mass. I have just taken any mass of aluminium. That is a given mass of aluminium. Yes or no?
Yes.
So when it is just the given mass of aluminium, what exactly does that mean? It simply means that, and I told you that 1 gram equivalent of aluminium we calculated, right? It was given mass, molar mass by valency. That was 9 grams, if you remember, initially. That if you write down this equation, aluminium shall gain 3 mole of electrons, will form, if loses 3 moles of electrons, will form Al plus 3 and shall lose 3 electrons. Yes or no? So when aluminium does that, so aluminium is going to be Al plus 3 electrons. Yes or no?
Yes.
So I would say 27 grams, that is 1 mole aluminium's molar mass, would lose 3 moles of electrons. So 1 mole electrons are lost by 27 by 3, that is 9 grams. So now you understand, I have one packet of 54 grams. The question says, how many gram equivalents are there? Calculate the gram equivalence of aluminium. Calculate the gram equivalence of aluminium in 54 grams of aluminium. Calculate the gram equivalence of aluminium in 54 grams of aluminium. So how would you work about it? Tell me, how would you work about it? So you will say that, one packet of 9 grams makes equivalent mass.
Yes.
So how many packets in 54 grams can I make? Should I divide 54 by 9?
Packet.
Because 9 6 are 54. So can I say number of gram equivalents
Is
is
2
going to be given mass
by 2.
divided by equivalent mass? No.
Okay. So number of gram equivalents is 2 here.
Why number? 1 gram equivalent packet has 9 grams of aluminium.
Yes. So there are 2 packets. There are 2 packets.
Not 2 packets. We have 9 grams, 1 packet.
Yeah.
Another 9 grams of aluminium, 1 packet. Another
Yes.
9 grams of aluminium, 1 packet. Another 9 grams of aluminium, another packet.
Yes.
Another 9 grams of equivalent aluminium. And another 9 grams of aluminium. So we have 9 times 6 is 54. So the question is that how would you divide 54 grams so that you get 9 gram packets of aluminium? Because that 9 gram aluminium packet is called 1 gram equivalent for aluminium.
Yes.
Do you understand my point?
Yes.
So 9 gram aluminium would be called as 1 gram equivalent for aluminium. So in 54 grams, how many such packets can you make? So you can make 6. So I would say that 9 grams aluminium makes 1 gram equivalent packet. So 1 gram aluminium would make unitary method 1 by 9 gram
Yes.
equivalents of aluminium. So therefore, how much 54 grams aluminium would make or would contain? So that would be 1 by 9 into 54, and that would be 6 gram equivalents of aluminium. Are you understanding? So 54 grams of aluminium would contain 6 gram equivalents of aluminium. Are you understanding or not?
Yes.
Right? So we would have this 6 gram equivalence of aluminum. Right?
Yes.
Right. So how, now let's suppose if I give you for magnesium, calculate the number of gram equivalents in 480 grams of magnesium. So do you remember that the equivalent mass of magnesium was how much? 12 grams? Because what is equivalent
Yes.
mass? That mass which can release or gain 1 mole electrons. So we calculated that magnesium's atomic number is 24, atomic mass is 24. And it forms Mg plus 2 by losing 2 moles of electrons. Are you understanding?
Yes.
So it is going to form what? 24 grams of magnesium
Plus
shall
40.
lose 2 moles of electrons. So 1 mole electrons will be lost by how much? 24 grams by 2, the molar mass by valency. So the first step is to calculate the equivalent mass. The first step is to calculate the equivalent mass, which is molar mass by n factor. For the element, it is magnesium. Valency is 2, molar mass is 24. You calculate. So this equivalent mass means if you have one packet and you fill in 12 grams of magnesium in it, that will give you 1 mole electrons. That's step 1. Step 2, what do? You say that 12 grams, either you apply straight away the formula. That number of gram equivalents is equals to given mass in the question upon equivalent mass. That is 480 divided by 12. 40 packets. That is one direct formula application. Second formula application would be, what would you say? You would say that you will say 12 gram magnesium makes 1 gram equivalent. So 1 gram magnesium shall make 1 by 12 gram equivalents, and hence 480 grams magnesium shall make 1 by 12 times 480, and that would be 40 gram equivalents. Did you understand my point?
Yes.
So you can divide 480 grams into 40 such packets, so that every packet contains 12 grams magnesium, and such that every packet releases 1 mole electrons. So can you simply straight away say that 480 grams of magnesium can be divided into 40 gram equivalent packets, and such that every packet contains 12 grams magnesium and every packet is releasing 1 mole of electron. So in totality, can I say 40 gram equivalents shall release 40 moles of electrons?
Yes.
And I can also say that 480 grams of magnesium shall release 40 moles of electrons. Any doubts in this? Just tell me. So this is how you calculate the number of gram equivalents, and you also calculate the equivalent mass. Any
Yes.
doubts in this?
No.
Got the point?
Yes.